In this video, we're going to talk about the unit circle, which is a powerful tool to help us figure out the values of the trigonometric functions at different angles. So to start off, the unit circle is simply a circle with a radius of 1. Once we know this, we can drop a vertical line from the point where it intersects the circle, right here, so that it forms a 90-degree angle with the x-axis. This is now a right triangle, and so we can start using the Pythagorean theorem to figure out a few different pieces of information about it. So let's assume that this angle is 45 degrees, and because they all need to add up to 180, we also know that this angle is 45. The sides across from equal angles are also going to be equal, so we have both of these sides equal to x. And now we can plug them into the Pythagorean theorem. So we'll do that quickly up here. X squared plus x squared equals 1 squared, since that is the hypotenuse here. Then we'll have 2x squared equals 1. X squared equals 1/2. Square root of both sides. X equals square root of 1 over square root of 2 equals 1 over square root of 2. And then we're going to multiply top and bottom by square root of 2. So that's going to give us x equal to square root of 2 over 2. So this point here is square root of 2 over 2, square root of 2 over 2. So that's doesn't seem super crazy, but the next part is crazy. Now, if we want to find the cosine of this angle, let's actually call this theta now. Clean this up. If we want to find the cosine of theta, is going to be the adjacent side, which is, we figured this was square root of 2 over 2. It's going to be square root of 2 over 2 over the hypotenuse, which is 1. So basically that just goes away. Cosine theta equals square root of 2 over 2. So that's kind of interesting. Now let's do it again for sine of theta. So sine is opposite, which again, this is square root of 2 over 2. So we're going to have square root of 2 over 2 all over the hypotenuse, which is 1. So again, this goes away, and we have that sine theta equals square root of 2 over 2. All right, now we have something pretty cool to look at. What we'll see is that for any point along the outside of this circle, the x value is going to equal cosine. So if we have x, y, it's going to equal cosine theta, and then the y value is going to equal sine of theta. So now we can see that just from this one example, how we can start forming a visual representation of all the different trig values and where they land on the circle. Okay, so now what we're going to do is we're going to plot a few angles here. So we plotted 45 before, and now I've added 60 and 30 degrees. And again, I've got our little reference equation down in the bottom here. This one is equal to square root of 2 over 2, comma, square root of 2 over 2. Using similar math, we can also figure out the x and y values for these angles. In this case, this one is going to be 1/2 square root of 3 over 2. And this one is going to be square root of 3 over 2, comma, 1/2. So just by looking at this, we have a lot of repeating numbers, and that's what makes this whole circle super useful. Basically, there are 3 values you need to remember, and then you'll be able to figure out every value in this circle. I've drawn the lines here, red, blue, and green. The red one is going to be radical 3 over 2. The blue one is going to be radical 2 over 2. And the green one is going to be radical 1 over 2, which basically just boils down to 1 over 2. So knowing this, what we can do, actually I'm going to copy that. We can turn this on its side. Let me just make sure I get it right. And then we're going to flip it. And then we're going to line it up here. And then we can start seeing some cool stuff. So, for example, let's look at angle 45, the one that we derived earlier. So this one is at the intersection of the two blue lines, and we can see over here that blue is radical 2 over 2. So what is our x and y value? Radical 2 over 2, comma radical 2 over 2. All right, and then if we look at 60 here, we have the short line, which is green, 1/2, and the y value is the red one, radical 3 over 2. And so there we go. Same thing for angle 30. The x value is this red line here, which is the long one, radical 3 over 2. And then the y value is the green, 1/2. So we have these three values. That's basically we're just going to use everywhere. The only extra thing you need to know is that, if I can get it green here, because sine is the y value, sine is going to be positive in these two quadrants. So sine is positive. And these two quadrants, sine is negative. Similarly, because cosine is the x value, cosine is going to be positive over here. Cos is positive. And is going to be negative over here. All right. So now what we're going to do is if we plot all of the angles, I have to hide some of these things for right now. We plot all of the angles, we can start seeing how the pattern will basically repeat. Now that we've established what the unit circle is and how we can use it to visualize the values of the trigonometric functions, we're going to run through a couple of practice problems. So on the left here, I have a few values that we want to find, and we're going to start with the sine of 135. So when we're doing this, the first step is always to figure out where that angle is on the circle. 135 is in quadrant 2, so now we know where it is. Second step is to figure out what coordinate we're looking for, x or y. This is sine, so we're going to be looking for the y value. And step 3 is to take our reference lines and basically put them over top of the circle. We can see here that the middle line, our square root of 2 over 2, is the one that lands on 135. So that's going to be our first answer, square root of 2 over 2. Now we're going to move on to the second question, cosine of 225. First step again, figure out where it is on the circle. Figure out what coordinate we're looking for. This is cosine, so we're going to be looking for x. And then we're going to put our lines on top of the circle. So in this case, it's still the blue line, so we know from the last one that this is square root of 2 over 2. The only tricky thing here is we have to remember that cosine is negative on this side of the plot. So we're going to have negative square root of 2 over 2. Not too difficult. Next question, sine of 315. So we're going to figure out where that is down here. We're going to figure out the coordinate we want, which is y. We have to flip our visual lines a little bit, but then we just, again, put them over top of the circle. And again, square root of 2 over 2. But y is negative underneath the x-axis. So this one is going to be negative square root of 2 over 2. So that's really the most difficult thing, is just remembering that, like, if you're in a quadrant where the x or y coordinate is negative, you have to remember the negative sign. Now we'll move on to the sine of pi over 3. So again, you'll need to know the unit circle in degrees and radians. You do this a bunch of times, it'll kind of come second nature. But sine of pi over 3, where does that land? So it's actually, it's actually right here. So I didn't reduce this fraction just because I wanted to show that this is divided into sixths. So 3/6, 4/6, 5/6, 6/6. But really, this goes down to pi over 3. So this is what we're looking at here. Now we want to find the sine, so that's the y-coordinate. So we're going to take our reference lines, flip them, put them here. This time we got a different color, so we got our long line, which is square root of 3 over 2. And we're in a quadrant where sine is positive. So if I can get my pencil right, this is going to be square root of 3 over 2. Next question. Cosine of 5 pi over 3. So that is actually this one. So 10 pi over 6 goes down to 5 pi over 3. Get rid of the circle. Equals 5 pi over 3. So we know where we're at, and now we need to find the x-coordinate because this is cosine. So we're going to put our lines over. And the lines aren't perfectly measured, but the idea is the same. The green one matches up with our 5 pi over 3, and green is 1/2. That's the short one. So this is 1/2. Oops, wrong line. Okay, we got two more. 7 pi over 6. Where does that land? So if we're looking around, that one's actually labeled right here. And that's 210 degrees. And we're looking for sine, so that's the y-coordinate. We're going to take this, flip it again. And we got the green one. So we're at 1/2, but we're in the third quadrant. So y-coordinate is negative. This is negative 1/2. All right, and the last one, cosine of 2 pi. So I added this one in here just because you should also know that the points at each of the axes has a value. So this one is, 1, 0. This one up here is 0, 1. This one over here is -1, 0. And this one here is 0, -1. So I didn't really label them before, but it's kind of pretty simple to see that based on where the circle is plotted. So cosine of 2 pi. 2 pi is the full circle, so that is right here. And we're looking for the x-coordinate. So we have 1. So cosine of 2 pi is 1. I hope this visualization helps you. This is definitely how I think about it whenever I'm trying to figure something out quick. Just like I have these 3 lines, and I just kind of visualize where they land, or how do they fall onto the angle that I'm looking for.